The continents are not sitting motionless. Rather, they're sitting atop the mantle on plates such similar to rafts in an ocean, floating without direction. With all these massive continents floating around the globe, logic dictates that at one point they were either together or they have collided, right? Well, that would be correct. They were all together in one massive supercontinent called Pangea. Granted, with this theory, some people are very skeptical and feel the need to see evidence, claiming that there is none. Well, there is in fact three huge pieces of evidence support the theory of Pangea. For example, all the continents fit together, like a puzzle, suggesting that they're all once together. Earth's crust is not whole. Matter of fact, it is divided into separate sections called plates, and these plates are always moving. Now, with that being said, one commonly asks, how much are they moving, and how are they moving? To answer the first question is simple. They're moving very slowly under and cover a distance of only a few inches per year. The second, well, that's a bit more complicated. To understand this, first you must note that the man.
There are three different types of plate boundaries. There's divergent, convergent, and transform. In the divergent boundary, plates are moving away from one another, and as they move away, magma rises, destroying or recycling the crust. As a result, volcanic mountain chains, such as the Andes, are created. Some examples of divergent boundaries are mid-Atlantic ridges, Iceland rift areas, East African rift, Lake Baikal, and the Red Sea. The next plate boundary is the convergent plate. These plates move toward each other, and though there are different types of them, they all collide and destroy the crust. There are three different types of convergent boundaries: oceanic-continental, oceanic-oceanic, and continental-continental. Oceanic-continental results in a subduction. Oceanic sinks because it's more dense. The second type of convergent boundary is the oceanic-oceanic. This is where the oldest crust subducts, making volcanic island chains appear. Last type of convergent boundary is the continental-continental. This results in mountains such as the Appalachians, Himalayas, and Rockies to form. The last plate boundary is the transform boundary. Plates sliding past each other. However, the movement is not smooth due to friction between the rocks of the two plates. Therefore, sometimes the two plates would get stuck and locked together. But since the convection currents of the underlying magma are still dragging the plate, much tension and pressure is built up at the transform boundary. Where there is a sufficient buildup of pressure, rocks in the plates break up and get jerked apart. This results in earthquakes.
Plates are destroyed when two lithospheric plates meet. The denser plate ducts underneath the less dense plate.
Seafloor spreading happens due to volcanic activities. The plates diverge and cause stress to the lithosphere, and thus a basaltic magma spills out of it. When the magma rises, it cools down and creates new ocean floors. The further the rocks are from the spreading zone, the older they are, and the closer they are to the zone, the younger they are. Mid-ocean ridge is an underwater mountain that consists of many mountain chains. They typically have a valley, also known as a rift, that runs along the spine created by the plate tectonics. Mid-ocean ridges are the boundaries of two plate tectonics. There are two formation processes: ridge push and slab pull. A ridge push happens when the bulk is growing from the ridge and pushes the other part of the tectonic plates away from the ridge, most likely towards the subduction zone. When the plates are being pushed to the subduction zone, it is being pulled under the dominating plate and dragging the rest behind it, also called a slab pull. Sometimes there are slow spreading ridges, like the Mid-Atlantic Ridge, that often have a much larger and wider valley. They can be as large as 10 to 20 kilometers wide and usually have very coarse region. Faster spreading ridges like the East Pacific Rise are very narrow, have sharper edges, and are around flat grounds that gradually slope away from the ridge over many hundreds of miles.